key value store databases, there's many that are out there, and here are a couple listed. And Facebook uses one called Memcache, and how it uses it is that it retrieves strings or objects that are associated with keys, and then it projects those onto the web page. And this happens millions of times per second with all the users that are connecting on Facebook. So typically how this happens is that a networking packet comes in with a request, and that packet goes up through the networking stack, through the operating system, and into the application where it gets processed. And the application will retrieve the value from storage, and then it will send a reply packet back down the networking stack to the user. Now this process is very slow, and we can speed that up with the FPGA. In the FPGA, we're going to keep the networking packet request in the physical layer and process the request, retrieve the data, and then send out a reply without ever going up the networking stack through the operating system, and we'll be able to achieve very low latency by doing that. I have decided to go with the Terasic DE5 Net FPGA development board because it has 10 GB per second Ethernet, and then it has the Stratix 5 FPGA as well. On that FPGA, there are hard transceiver IPs, and those implement SerDes, also PMA, and then PCS as well. And then you can also instantiate a Mac IP, which is a soft IP provided by Intel, so that your communication with the networking is through an Avalon streaming interface, which is very convenient and nice for a developer. It also has SRAM on the development board so that we can store values, and there are a couple other peripherals on here which we don't have to worry about. Maybe PCIe Express is a good one to mention because I'll be incorporating that in the design. So I'll be explaining my step-by-step procedure on how I'm going to execute this project, and I engineer in small steps, making sure that those steps work, and then building off that. So first I'll just start with a standard control register in the FPGA that will set and control an LED, and then it can read from a switch. From there, I'm going to communicate with that control register over PCIe, and being able to do that in the CPU space. So I'll create application drivers that can set the LED and that can read from the switch. From there, I'll create a graphical user interface using Visual Studios that will use my API and create a nice interface for the user. From there, I'm going to gut the functionality of the LED and the switch, and I'm going to create a packet generator so that I can start the process of doing the networking. The control register will set, it'll configure how the packets look, like the MAC address, the IP address, maybe how frequently the packets get sent out, and the data in the packet. From there, I'll instantiate the transceiver IP and the MAC IP. I have already been looking at all the data sheets. I've been taking Intel courses on how to configure and instantiate the IP, also the MAC IP, and currently right now I am looking at and I am taking the courses provided on the Intel website on the PCIe IP, how to configure that and how to get it working in your projects. Okay, from there I want to be able to use the PCIe Express to configure the MAC IP, and there are just some configuration registers in there. And then I also want to receive packets, and I want to bring them into the CPU space and present them on the graphical user interface. So how this whole thing is working is that a packet is being generated, and then it is being sent out, the transceiver IP. Now, 10 GB Ethernet is full duplex, so you can transmit and receive at the same time. So I'm going to transmit and then just cycle the wire back into the receive side, receive the packet, bring it down into the PCIe Express, and then into the graphical user interface. Once I get all this working, then we're going to gut it again to gear it up for the key value store. So we're going to keep the transceiver IP and the MAC IP, and we're going to keep some of the graphical user interface down here. From there, I'm going to create a packet parser so that when I receive a packet, I can parse it given the protocol that is used by some of these key value store databases. I'm going to be using some of the open source ones. After that, I will create the key value read and write logic, which is pretty much going to be a hash table that will take the key, hash it down to the available addressing space of what my SRAM is, and then retrieve the value. Then, once it retrieves the value, I'll construct a packet that will then get sent back to the MAC IP, and then it'll use the transceiver IP to send it back out onto the network. From there, I want to create configuration registers that will configure the packet parser and the packet constructor to use different database protocols, so that maybe I can do it for 3 different open source databases. And that concludes my project.